So I come from Spain, and a few centuries ago, Spain used to be a big empire. Not anymore. But during that era, we used to create a lot of concepts and export them to the rest of the world, to other cultures. You can call it intellectual property if you wish. During that era, we created concepts that were so popular that other cultures decided not only to adopt the concept, but also adopt the Spanish word for that. And as a native of the country who created one of those concepts, although I'm not a very good practitioner of it, I know that I have a challenge with you because of siesta. I know that it's very tempting to take a nap for the next 30 minutes. But I will try my best to keep you interested in the topic that I'm going to share with you. And I promise to share experience more than knowledge, okay? So feel free to ask questions if you want about the topic itself. I will try to have the 10 minutes for Q&A later. But this is based on what I have learned through the years. So it's perfectly arguable that you have a different opinion on how to do things. I'm going to talk about architecture. As a video was saying before, I'm the non-human part of the conference. And I'm going to talk about a technical topic, but somehow I expect it to be related to your experience on applications. So let's start with this. And I'm going to start by introducing what software architecture is. And I hope that we will agree on what I refer as software architecture. We will then be talking about long-lived apps and why I think are more relevant in terms of architecture, the concepts that I want to share with you. Then I will briefly give you some ideas about things that you can do in order to improve what you already have. And finally, we will talk about a higher level, some hints on a strategy on how to improve your architecture. So let's start with software architecture, and probably one of the people that will come to your mind if you are an expert on this field, or at least if you have read a little bit about it, is Martin Fowler. Martin Fowler is a very well-known person about software architecture, and he has an article that has been, or I don't know if it has been updated recently or it was created recently, but it is not that old. And in that article, he was even saying, well, there's no full agreement on the industry on what software architecture means. I mean, like we have some not very well-defined agreement on what we mean. So some people may refer to software architecture referring to some topics, and some others will include some other topics. So the problem here comes from using a metaphor. And probably most of you have already compared software architecture with traditional architecture. And that is not bad in itself, because traditional architecture comes from the idea of building, of the art and techniques on building houses and other constructions. So there is something that we can refer to that is very comparable, that is the art and techniques to create good software. Okay, I can relate to that, I hope you can too, but I would like it to be a little bit more detailed than that. And most people think that we are referring to software architecture in terms of a snobby term, okay? We want to be, hey, we are not developers, we are software architectures, which is far more than a software developer. At least I want to be paid more than a software developer. So the thing is that even though some people may consider this snobby, I don't think it is. I think that there are some concepts that are behind this software architecture that I hope that you agree with me on what they are. The first one that comes to mind is the use of design patterns. And design patterns also come from traditional architecture. The way you solve some generic problems in a way that may apply to different situations, but that you have to adapt to your actual implementation. So yes, we have that, and that is part of software architecture. Another thing that is very important in software architecture is how you organize your code. I'm not talking about your code, because I know that it's very neat, very clean, but anybody else's code, very likely they have their code not very well organized. You go into the repo and you start reading those smells of why is this here? Why does this class belong to this file or this folder? All these things that if we have a very well-defined architecture, hopefully you are able to tell by the meaning of the class, by the type of thing that this class is doing or any other type, you would be able to point to where it should be stored, for example. Another thing that is important, and that is somehow related to what Dan presented to you this morning, is how we organize the code, how we define what happens in the front end, how we define what is mobile development and what has to be done there and what has to happen in the back end. So how we distribute the responsibilities between what happens on one side of our code and what happens on the other. That is very important too, and we want to define that in the architecture. So sometimes you aim to have a software architect that is able at least to have enough knowledge of the whole application, not just the back end, not just the front end, but a whole picture of the whole system. So this person is able to design at least the high level of the different pieces that are intercommunicating. But most of all, when you talk about architecture, you want two features or two characteristics that I believe are really important for your software. One of them would be maintainability, the ability to deal with the mistakes we make. We make mistakes, well, not you, but I make mistakes, okay? And when you create those bugs in your code, you have to fix them. And you have to know how these bugs are going to be located, how to make it easier for your future self to work with these problems that you are creating to yourself. Not only that, you want your code to be evolvable. You want it to be able to add new features as you need them, as the business needs these features. So it doesn't mean rewriting the whole software because I now have to introduce a new feature there. Do we agree on this, Barely? Hands against? Nobody? Nobody dares? Okay. So one of the first things that I listen to when I'm talking about architecture is, well, but I have a small app. It's not that relevant. I mean, like, it's only 1,000 lines of code. First, there is no one app with 1,000 apps, or 1,000 lines of code. This is just a demo or something very, very small. I mean, like, when we're talking about apps here, we're talking about something that initially may be small, but it may grow up with time. And when it grows, you want it to still be maintainable. You want it to be evolvable. So that means that you have to think about architecture from the beginning. Don't delay that process. The longer you delay thinking about architecture, the worse it's going to be for you. So hopefully, by this moment, we all agree that we should be doing something about architecture. Otherwise, I haven't done a good job on that. But now, I would like to focus on long-lived apps. And when I talk about those, I'm talking about things that make the evolvability and the maintainability more relevant. There are a few exceptions that don't match in this category. I mean, when you're talking about apps that are just a proof of concept and they're going to disappear, well, it's irrelevant. When you are talking about something that you create to understand your needs, but you're going to get rid of this application later on, probably architecture is not that relevant. But let's be honest here. I don't know how many of you have seen an application that was meant to be a proof of concept, and 5 years later, or 10 years later, is still working in your company. Can I see some hands, if anybody has seen something like that? Okay, a few hands, not many. Probably more than you think. If you ask in your IT environments, probably you will find some more than you expect. Some that have been created by interns that visited the company for a summer stay and created something, and this has been there forever. And hey, this happens. So The truth is that we never know how long our applications are going to last. I don't know if you know this. It looks like a Stonehenge, but it is actually the Spanish Stonehenge. So before we were an empire, we did also these things with stones, and we put these things here, and this is called the Dolmen of Guadalperal. And probably, if you ask your politicians, your most ambitious politician here, and probably will say no. But if you ask your politicians here and ask them if they expect their constructions, their infrastructure to be standing in 7,000 years as this thing is, they will say no. The things that I'm building now are not meant to last 7,000 years. And probably the person who started creating this was not thinking about that. I don't think that this person who stopped there and said, oh, I have this stone in my pocket, I'm going to leave it here and see what happens. I'm not saying that. But there was some purpose on building this, and it was relevant. But I don't think that they were expecting this to last for 7,000 years. So in most situations, the software that you build will benefit from defining a good architecture for itself. Okay, so let's talk about some small things that you can do to improve your software. And I have divided this into 3 different types of advice. The first one is how to prepare for success technically. So what technical measures you can take in order to improve the situation of your application. And I have organized those in 3 different scenarios in terms of time. What you should do as soon as possible, what is something that you should do in the short term, and what is something that you should do in the long term. Long term doesn't mean never. Long term means as soon as possible, but you don't have to do it neither today nor tomorrow, okay? So the first thing that I would recommend you to have in your software is to introduce tests. And probably some of you are thinking, well, I know that this guy has come sometime here to Romania to teach testing courses, so he's trying to sell me something. Not at all. The thing is that if you write software that is testable, your code will require to be somehow defined to have a better architecture. So it is very important that you introduce tests because it will force you to have this architecture defined properly. The other thing that you would like to have in your application is to add flexibility. What do I mean by flexibility? Well, I mean that you should be able to replace parts of your application without having to change the whole code of the application. The typical case here is in dependency inversion, which is a principle of the 5 close principles, the 5 solid principles. Thank you. I don't know who said that, but thank you. And if you use that, you are using a dependency in a way that you can replace it later. It is often the case that working for MongoDB, as I do, I get asked, oh, okay, but if I use Atlas or if I use Rail, I'm forcing myself to use that SDK in my application for good. And it is not true. You can isolate that as a dependency and have some interface that separates your code from that implementation. The other thing that may seem minor, but I believe helps a lot, is to have a single style in your application. What do I mean by that? Well, if you go into a repository of code and you can recognize the person who wrote the code, that's bad. If you can say, Ovidio or Maria wrote this, wrong. It should be the same style for all the pieces of your code. Because you want some style that you have agreed upon that is used in every single part of your source code. That's very hard because initially we start by spitting on somebody else's coffee because they use brackets here and I use it there. You don't want that. You want the conversation to happen early and to use a tool that forces you to use that style. Use a linter. They are meant for this situation. In the short term, you should add tests a little bit more advanced. Advanced in terms of what they are testing. They are not testing how the screws work in a car, but how the door will be ensembled altogether. So here we're talking about integration tests, pieces of your code that put together work as expected. Not only that, you should be starting to repay your technical debt. I don't know about you, let me make a wild guess, but sometimes you have deadlines that don't allow you to use the proper architecture or the proper implementation for your code. I don't know if this is the case, probably not for all of you, but sometimes you commit code that you are not very proud of, okay? You wouldn't want your kids to watch this code and say, Mama or Dad wrote this code. But you have a chance, you have another chance. In life, you don't always get a second chance, but here you do, and you should improve the quality of that code. You should use the Boy Scout rule, and every time you get into a piece of code, you should make it at least as good as it was or better, okay? And in the long term, you want to have tests that are acceptance tests, that are end-to-end or contract tests, so they, instead of just testing the pieces, they test that your application does what it's meant to do, okay? So a lot of testing, even though I'm talking about architecture, and some hints that are very easy to do. But if you do those, you will force yourself to organize things properly, to have things, to have dependencies separated, isolated in a way that you can inject them. So there are things that will come up as a result of implementing these technical measures. What else could you do? Well, if you are also preparing yourself for success, and in the non-so-technical field, I would recommend you to get good people for the team. Some people, particularly when you are at the beginning of some entrepreneurship adventure, as Dragos was mentioning this morning in his very inspiring talk, even for a non-Romanian, it is important to have good talent, to have people who care, to have people that will make the product, that will take it to the quality that makes us all proud of it. So we have to get good people. That means that if you pay with peanuts, you will have monkeys coding your code. You don't want that. You have to pay them, you have to have people who know their job, and you have to make them work together. It is a very bad idea to have silos inside of your teams. Oh, no, these are the back-end guys. Oh, no, this is the front-end people. So they cannot have coffee together. No, they should talk together, and they should agree on the best way of doing things, and they should learn from each other. Another thing that is important is that we have already learned that, but waterfall planning, if you are on the continuous improvement train, doesn't work very well. So I'm not here as an advocate of you have to use a Scrum or Kanban. No. Use whatever you please, but use something that allows you to implement continuous improvement in the code that you're writing. In the short term, I would recommend you to do code reviews. Constructive code reviews. No, this code is crap, committed never, okay? Not this kind of code reviews. You have to be kind with your colleagues, and you have to explain them to make it better. But you also have to listen to what they say, to learn from them and accept things that were not your initial plans. Because it doesn't matter how senior or junior a person is, this person may have very good ideas, and listening to this person might be important to you in the future. In the long term, I would recommend you to do postmortems. The term is awful. At least in Spanish, it means after death, okay? So, not what you want, but what I'm referring to here is to analyze after each stage or each sprint how things have gone. Did I commit to do more than I can? Did I do something wrong that didn't help the project? Okay, I want to learn from that, from a constructive point of view, so I can make it better in the future. Okay, But probably you are on the other side of the road. You are already successful. So how do you go about this? I mean, like, hey, success is here. I have already created this application that was meant to last 2 weeks, and 10 years later, we're still using it. So what do I do with it? Okay, so one thing that I would recommend you to do is to start, and if you're a keen observer, you will have noticed that the order in the tests here are the other way around. I will recommend you to start with the acceptance test. Why? Because testing units here is going to be impossible. Nobody thought about architecture as they should have initially, so injecting dependencies, separating the code is going to be a hell. So you don't want that. You want to do it from the whole view of the application. You want to test that everything works as expected, and then once you know that, you will be looking for seeds. You will try to cut and connect pieces in a way that is more testable. But first things first, you want something that will validate that you are not breaking the application that has been working for the last 10 years. That means that you are treating your code as legacy. There's a very nice book by Michael, the name escapes me now, but it's called Working with Legacy Code. I know the guy, very nice person, and a very good book, recommended. And basically, he refers to legacy code as anything that doesn't have tests, okay? So usually people think, oh, COBOL is legacy. No, your Rust code is legacy if it doesn't have tests now, okay? It might be very modern, it might be the latest language, you may have written it yesterday, but it's still legacy code because you didn't put tests in, okay? In the short term, well, the agile thing, one thing that I would like to mention regarding this is you may feel tempted to rewrite the whole application from scratch. That is something that always comes to our minds. It is not just not invented here, but we wrote it, but we know it's crap, so let's rewrite it, okay? And honestly, I don't know if you have a different experience, but in my experience, this doesn't work. You have an application, unless the thing that you are replacing is tiny, if the thing has an entity, if it is big enough, this is never going to work because you have to play catch up all the time. The established application will still be evolving, and you are trying to target a moving target. So you are aiming at this moving target, and you're never going to be able to shoot and kill the other application, okay? So it is a pain. It can be rewritten. I mean, I'm not saying that it cannot be done, but it's the amount of work that you have to put into that and the benefits that you get out of this amount of work are really not paying off, okay? In the short term, I would recommend you to start refactoring. That means that you have to have in mind some targets in terms of architecture. The first thing that we're going to do is to separate the UI, or if it is a backend, I'm going to separate the interface. I'm now using HTTP. I want to be able to use gRPC in the future. I don't know, whatever it is. But separate some layer and split that into things that now can be tested independently. In the long term, introduce unit tests. And that was the first thing that we were doing when we were doing things better, that was working with architecture in mind from the beginning. But now, since we haven't done that, we have to do it at the end, because only at the end we have the things separated and in a way that allows us to do the dependency injections and to work with all these pieces independently. Let's go into a little bit of higher level advice. Let's talk about strategy. The first thing that I would recommend you to do regarding these long-lived applications is deciding what is core in terms of your business and what is not. Let me give you a very, very clear example. I don't know how many of you have a big application running. I assume that at least half of you, if not all. But if I ask you, how many of you have written your own database? Not that you are using some database and have done some patch, which is still bold, that you have written your own database to have your application. I would be very surprised if you tell me that half of these people is creating their own database. The thing that you have to do is to look for the database that fulfills your needs. But I wouldn't recommend you, unless you want to compete with a company like the one I work for MongoDB, I wouldn't recommend you to create your own database. There are very good databases in the market. You know many. I can mention Oracle, which is a very typical one. If you want to work with open source, you can use Postgres. If you want to do something that is even more ambitious, you can go with MongoDB. And choosing what is the right tool for your needs is very important. Why? Because sometimes, I don't know, raise a hand here so I can have some hint about how much into detail get into this, but how many people know or work into microservices here? Okay, so I would say quarter of the people here. Okay, let me give you a very brief explanation on how things can be done in microservices, and probably not all of you will agree. But one of the methods to design a microservice is using the business logic to separate the things into the different microservices. And a typical methodology that you use for that is DDD, domain-driven design. Not domain-driven development, as some people call it, but domain-driven design. And in order to do that, one of the patterns that is used in domain-driven design is the aggregate pattern. The aggregate pattern is something that we use to work with the data that belongs together as a single entity. And you may have different pieces that are connected to this entity, but you deal with them as a single entity. So for example, if you're writing an application that writes invoices, you know that an invoice, typically in a relational database, you have like the header of the invoice that would be in a table. So this is invoice number so-and-so. That invoice has been done for this customer. This invoice is created on this date, and so on. And then you have a list of items that are going to be enumerated in this invoice. So at the end, you have like a grand total, taxes, and so on, but you have a list of items. Typically, in a relational database, these are two tables. One is for the header, the other one is for the items in the invoice. And you have a relationship that you have to visit every time that you want to build a single invoice. If you're using a document module, as MongoDB does, then you will have something that is a single entity, because an invoice is something that you want to work with it together. You don't want to work with the different parts isolated. So you want to add an item to this invoice, not add an item in general. You want to add an item to this invoice. So it's far more semantic, and that is what you should look for when you are using a tool. Gaspar was talking to us about being flexible before. I don't mean that. What I mean here is that you should be flexible to react to your change in your business needs. Let's agree on a couple of things here. How many of you have ever bought an application because the architecture was very cool? Nobody, okay? So this is not something that sells to your user base. Your user base couldn't care less about how your architecture is. The architecture is something for you as developers, for you as business developers of your application, for you as the owners of this enterprise, for you to work better, to be able to provide your users with the features they need, with the quality of software that you want to provide them with. That is not something that is really relevant to them. But you also have to be aware of the needs that come from your business. So how many times have we seen that, hey, we have this feature that is very important, but now we have changed our mind and we want to implement something that is completely the opposite. That happens very often, because then when we put something in the market, we realize, oh, this is not what we were expecting. This doesn't have the result that we were expecting. This is not what we wanted when we implemented this feature. Or it is not working as we wanted. So we are going to try new ideas. And then you want to be able to replace parts of your application without damaging yourself, without hating yourself for thinking, oh, I should have thought about making this flexible enough so I can change it later. One example that I can give you is when you're talking to your front end, there are several ways to address your front end. And if you're writing mobile applications, as Dan was explaining to us before, you have several options for implementing those. But also, you have several options for talking to the backend. You can go and implement your own REST API and talk to your backend in the way you want. But you can use some tools that come from some of the implementations. For example, MongoDB has SDKs for talking to the front end. And you can go and implement Realm, which was a database SDK that was acquired by MongoDB to get synchronization with mobiles. But you can use an API that is provided by the database. So the only thing that you have to keep in mind is, how do I keep this flexibility? How do I allow myself in the future to switch from one to the other? Let's say that now I'm more interested in synchronization, then I want to go with the SDK, or now I want to implement the synchronization in a different way that doesn't solve conflicts or whatever, and then I want to do it in another way. Then if I have isolated this layer, then I can go and change this code as I want. So introduce flexibility whenever it makes sense. The other thing that is relevant is how to keep your application up to date. And not only because of the security threats that Tudor was telling us this morning, but because you don't want to make these gaps, the switching from these logarithm curves and exponential curves that were mentioned before. You want to be jumping, so the jumps that you have to do are not huge. There's nothing worse there's no worse experience in a big enterprise than a huge migration, something that is a go, no go migration because everything is changing under the hood. If I go with a new application, I cannot use the old application anymore. If you incrementally change the application, you will be happier. And the good news is probably going to be cheaper. You have to constantly pay for that, but in the end, it's going to be cheaper. Making a full, like playing Indiana Jones and putting the bag on one side, getting the idol on the other and switch, that usually doesn't work very well. Finally, regarding architecture, it's very important that you don't define architecture based only on technical reasoning. It is a technical measurement. It is a set of techniques and the art of building good software. But you should measure those against your business goals. Do I have to provide this flexibility here? How much is it going to cost me? Is it going to be required in the future to add some features and remove features here? And if I do, will I make it easier if I introduce this flexibility? So by knowing what your business is going to do in the future, you will be better off to take technical decisions of your software. I think it was Winston Churchill who used to say that the strategy is important, but look at the results once in a while. So here, you have to look at the results from the perspective of the business. Okay, so that said, I would like to quote Master Yoda, do or do no, but there's no try. But I want to have a more positive thinking, do and keep trying, because I think that iteration is important in software development. So you don't have to come up with the best solution on the first hand. Try these measures and any others that are advices that you believe are valuable to your environment. And with all these things, try to continuously improve the quality of your code base and do it with the perspective of the business. So, mulțumesc frumos. I really appreciate that you have been mostly awake. I have reserved 5 minutes for Q&A. Glad to take any questions if you have. Otherwise, feel free to catch me later, and I will gladly talk about this and other topics. Please.
Hello. You mentioned at the beginning that architecture is important from the beginning as when you're building the project. How do you explain this to a client or the management that if the client wants to build an MVP, it's still important?
Yeah, that's a challenge. So let me repeat the question, rephrase it. It is very hard. You didn't say that, it's my words, but I believe that what you meant was it's really hard when you're selling a product to somebody else to convince them how important it is, even if the sale is internal in a company, to convince them that you have to put some effort into architecture from the beginning. And I would agree with you. I agree that sometimes even the fact of testing is very hard at the beginning. But I usually use an example that if you're a front-end developer, you will know the pain that I'm going to share with you. If you're a back-end developer, you will say, hey, that for the front-end developer, sometimes you get hired to have a project finished by some date. Funny enough, that is the same date that the back-end is going to be finished. So, has it happened to you or any of you here? It has happened to me a few times, okay? So you're supposed to have some code working with something that wasn't stable yesterday. How do you do that, okay? And that is one place where architecture can help you to succeed. The good thing about implementing these abstraction layers that I was mentioning before, the dependency inversion principle, is that, hey, I'm going to have this layer that is going to be talking to the backend, and I expect this set of responses when I make these requests. But I'm not working with the backend. I can talk to the guys in the coffee machine. I should learn from them. They should learn from me. But we are not going to spit each other in the coffee. We are going to be good friends. And last week, we are going to have a deadline to have things to be stabilized, and then I will work on the integration. I will delay that part of my code till the last point in time where I can do that. And I can do that because I have used some architectural principles. Otherwise, you have what you have in many projects. That is, I have a moving target, that is the backend, and then when things change in the backend, my code doesn't work anymore. And it's not them to blame, it's you. Is your code the one that gets blamed for not working properly with the backend? So having this flexibility, it has some costs, I'm not denying that, but the cost is clearly recovered through, not through the years, through the immediate time of the project. So that would be, you can use different strategies, but I would recommend you to do so. The other thing that is important here, and I hope that you agree with me on this one, is that if you go to the doctor and you have to go under surgery, you don't tell them whether they should wash their hands or not. They better do. It's their knowledge that they are applying there. It's their best practices that they are applying to do what they should do there. So you, as a software developer, as a software architect that earns more money, you should be telling what is the right path to implement your project. And if you agree with me, the right path is by taking care of the architecture at the beginning. That is what I would recommend as a doctor. If you go under surgery with me, I will wash my hands and introduce architecture.
So I was wondering, besides measuring the business goals, right, what can you do to prevent over-engineering?
Yeah, that's an excellent question. His question was, how do we prevent over-engineering? Because, yes, I mentioned measuring against the business goals, and there is always the risk of entering into the analysis paralysis, writing structures that are Gothic for your application and that are really not needed. That is where common sense and experience help. I mean, like, yes, you and your building, again, you have good professionals that you're working. Let me point to the slide that I was mentioning regarding the people that you work with. The people that belong to the team is very important. They have to know how to do things. If you only have junior people, and don't get me wrong, I have been a junior, and I have learned, and I have made mistakes as a junior, and I still make mistakes as a senior, okay? So, but my experience, hopefully, through the years has improved, and I have a better taste, I have better understanding of what is needed and what is going to be a waste in the future. So by having good professionals that have been involved in previous projects, you have some taste of what is needed and what is not. Let me come back to the definition that I gave you, is the art and methodology, but the art. So there are some parts that are not really measurable, that are not really objective, that depend on the quality of the professionals that get involved in the project. If you start a project that is very challenging only with junior people, hey, they might make a very good work. Not arguing against that. But if you only pay for junior, you will only have junior experience. And if they make mistakes, it's you to blame, not the junior people. You have to keep that in mind. If you put people in the mix that have a little bit more experience, probably what they will bring to the table, if you have done a proper selection of these people, is that knowledge to apply when something is needed and when something is over-engineering. And there's no black or white rule that I can give you. I would love to, but I couldn't give you like a single rule that if it is more than 5, don't do it. If it is less than 5, do it. No. It's more based on experience, on an estimation, on the situation, on the project. So, sorry for not being more precise, but I think it's a fair answer, okay? Any other questions? I think we're over time.
Thank you very much.
I'm done. So,
thank you, Jorge.
For those who wanted to ask, catch me later and I will be glad to answer.